my name is Barun Dutt and I'll be telling you about Large Applications Practicum. In this lecture, we look at Git and more advanced concepts in Git, particularly related to branching and merging. So let's get started. So we have already looked at the concept of branching in the last lecture. And basically to check out a branch you wish to merge, so we have already looked at that we can create a branch. In this case, these are the different commits. This is my master branch. And I have already created a branch and I have made 2 commits on this branch. So you can actually now, if you want to merge this particular branch into the master, you will first go on to master by checking out master. And then you will actually do git merge ISS53. So sitting on the master, you will try to merge ISS. And this is how it will happen. Now, generally, instead of just moving the branch pointer forward, Git creates a new snapshot that results from this 3-way merge. So if ISS gets merged into master, it will create a new snapshot. In this case, the C6 commit, which will be the case where the things get merged. So the code in the branch will get merged with the code in the master and it will create a new commit. And this is referred to as the merge commit, as it is special that it had more than one parent being this one and one parent being this one. So now, if you change the same part of the same file differently in 2 branches, which may happen in certain cases, and you are merging them together, there will be a problem because there will be a conflict. So Git won't be able to merge them cleanly. So in this case, if suppose I'm sitting on the master branch and I write git merge ISS53, so and if there is a change on the same part of the same file or the same line, then conflict will happen, and merge conflict, as you can see, is reported here in index.html, and therefore we need to fix the conflict and then commit the results. So if you want to see which files are unmerged at any point after a merge conflict, you can run git status, and here you can see you have unmerged paths, and these are the unmerged file. These are the file which have not got merged. And in general, you will have to open the file and you will have to resolve this conflict and then try merging it again, the file which is available on the ISS53 branch. So, resolving the conflict, anything that has merged conflict and hasn't been resolved is listed as unmerged, which we have already seen. Git adds standard conflict resolution markers. So basically there are certain markers which get added to the file that have conflicts in the head. So you can open them manually and resolve those conflicts. And it is easy to see where the conflicts are happening. If you want to use a graphical tool to resolve this issue, you can run something called git merge tool, which is written here, and which fires up an appropriate visual merge tool which walks you through the conflicts. So if you had to do a visual merge, you can do git merge tool, and then it will start the merging process by doing a graphical merge between that file, say in this case index.html, with the local copy and the remote copy. That is one which is on the master branch and one which is on the ISS53 branch. So now the git branch command does more than just create delete branches. If you run it with no arguments, like for example write like this, you get a simple listing of current branches. So in this case, if we just write and if to see the last commit on each branch, you can also add a -v flag. So -v flag. So git branch -v will show you all the commits on all the different branches which have happened. So for ISS, one particular commit has happened, last commit. Master, this commit has happened, and on testing branch another commit has happened. To see which branch are already merged into the branch you are on, you can write git branch merged and it will show you that ISS has already been merged with the master branch. You can also do branch deletion. So if you write git branch -d testing, so the idea is firstly, if the branch is not merged, it will not allow you to delete. If you are sure you want to delete it, you can write it with a capital D -test. So what's happening is that if the branch is not merged, it will give an error. It will not allow it to be deleted. But if it is merged, it will delete the branch. So if you really do not want to delete the branch and lose that work, you can force it with -D and helpful message points out. So basically this -D option is a stronger one. It will still delete the branch without merging it, which looks a little awkward. Generally when we branch, we will resolve conflicts and we will merge it and then only delete that branch. So there is also certain techniques for pushing that branch which we have been working on to the remote repository, say on the GitHub page, which it is tracking. The local repository is tracking a remote repository. So when you want to share a branch with the world, you need to push it up to a remote that you have to write access to. So you will write git push origin server fix, and as you can see, it will compress and it will write the object, and it will actually write the server fix branch to the remote server fix, which is located on say GitHub, which it is already tracking. And to merge this work into your current working branch, you can run git merge origin server fix. In that case, if you want your own server fix branch that you can work on, you can base it off your remote tracking branch. So in this case, if we do checkout -B server fix origin server fix, branch server fix is set up to track the remote branch server fix from origin, switch to a new branch server fix. So basically this is where you are actually tracking your current branch, your current working folder on that branch is tracking that remote server, which is also having the server fix within the origin. So now different name from the remote. So one other idea is that suppose you want to set up a local branch, but you also want to give it a different name than the remote branch. You can do the same kind of thing by writing git checkout -B SF origin server fix. So branch SF is set now to track the remote branch server fix from the origin and switch to the new branch SF. So you will switch to a new branch SF, which is tracking the server fix branch on the remote server. If you already have a local branch and you want to change the upstream branch you are tracking, you can use the -U or set upstream to option to git branch to explicitly set it to at any time. So if you write git branch -U origin server fix, branch server fix is set up to track remote branch server fix from origin. So this is how you will set up any branch to track a remote branch. And this is useful because once you track it, then you can merge with it, you can push things to it, and you can also check out things from it. So one other concept here is pulling and deleting remote branches. So remember that while git fetch command will fetch down all the changes on the server that you don't have yet, it will not modify your working directory at all. It will simply get the data for you and let you merge it yourself. This is what we had looked at it in the last lecture. However, there is a common command called git pull also, which is essentially a git fetch immediately followed by a git merge in most cases. If you have a tracking branch set up, as demonstrated in the last section, either by explicitly setting it or having it created by you by clone or checkout command, git pull will look up what server and branch your current branch is tracking, fetch from that server, and then try to merge in that remote branch. So we can also do deleting the remote branches. Suppose you are done with the remote branch, say you and your collaborators are finished with a certain feature, and you have merged it into your remote master branch or whatever branch your stable code line is in. You can delete the remote branch by using this delete option with git push. If you want to delete your server fix branch from the server, you run like this. So git push origin delete server fix. So basically what will happen is it will delete the remote branch. So basically all this does is to remove the pointer from the server. The git server will generally keep the data there for a while until garbage collection runs out. So if it was accidentally deleted, you can also recover it. So remember that if you're done with the remote branch and your collaborators are finished with the feature and have merged it into the master branch, you can delete the remote branch. So this is actually deleting the remote branch server fix from the Git remote repository. So now we have learned a number of steps in Git. Actually, you have learned not only the simple but also advanced features of Git. You can use Git for your own advantage in tracking large projects and development where files can be changed. You can revert back to prior versions. At the same time, you can do development in a distributed manner with other team members who are also using the same repository, the same GitHub page, checking in and checking out code. We have used the resources on the Git SCM page for this lecture, and we appreciate that you check chapter 3, particularly in Git SCM docs, for more assistance and help. I would like to acknowledge my TAs who helped me prepare this lecture. Now is the time for the activity. So in this activity, we are going to again try out things which we have learned in this lecture. So now, building on the prior activity, we now have to revert to the code on master branch. So we have to move to the master branch. So check out the master branch. On this code, create some more changes, reverting back from printf to cout statement and commit your code. So we are moving on the master branch. Now merge the bug fix branch to the master branch. So we will have to check out the bug fix branch and resolve any conflict. Particularly this branch was meant to solve for negative numbers, where the factorial may not exist for negative numbers. So resolve any conflicts while merging your code. So we will do the git merge, and we will have to resolve the conflicts in the master branch and remove, and basically the conflict resolution markers will be in the file. And you will have to remove those conflict resolution markers while you are resolving the conflict. And you will need to stage the files again with GitHub git -a-m command, and then check and commit them after resolving the conflict, which will create a merged commit. Now push your code to the remote GitHub repository, which we have also learned, including the bug fix branch code, and finally delete the bug fix branch locally and also from the report repository. So you can try these steps based on the material covered in this lecture, and we look forward to connecting again in the next lecture on new concepts in large applications practical. Thank you.